Hello everyone. So today in this video we will be discussing about a problem from Pathfinder optics. The question is from Check Your Understanding, question number 9. Let's read the question. 2 point sources are at a distance 24 cm apart are placed near a converging lens in the plane of the optical axis of the lens and the diameter of the lens. Okay. In the given figure, location of the sources and their images are shown by 4 dots. 3 dots are on the vertices and the fourth is on the centroid. Find the focal length of the lens. Now, there can be two cases. Either S is at the both the sources, that is, which are marked by S, is at the vertex, or one source is at centroid and the other at vertex, and both the images are at the opposite vertices of the triangle. Pause the video, give it a try. Now I'm solving it. Hope you tried it for a few minutes. In this case, in this problem, I'll be discussing about one case only. The case is S1 at centroid, which I'm representing by G, and S2 at vertex A. Right? Now, suppose this is my triangle, and here is S1, here is S2. I assume the images here are I1 and I2. I can assume it to be I2, I1 because the case looks symmetric. Even if you consider the right hand side to be I1, then the image is just flipped vertically, right? Now consider a little theorem. You can treat it like a theorem. This is my lens and the perpendicular bisector is my axis. Consider 2 points A and B. It has corresponding images C and D. Okay, B, you can say, since it's a convex lens, we are assuming to be a convex lens, D to be the image of B and C to be the image of A. Now the theorem says that the line connecting A and B, the line connecting A and B, as well as the line connecting C and D, 1 minute, as well as the line connecting C and D intersects the lens system at some point P1. And since we consider the corresponding image of A to be C and corresponding image of B to be D, I can say that ray through A and C, a line through A and C, as well as a line through B and D. I don't know what's happening. Will intersect the lens system. Well, the diagram is not to scale, that is why it's not looking, but it actually intersects the lens system. So I'll get some point P2. The same thing will be applying here in this problem. The line joining S1, S2 and line joining I1, I2 will give me point P1. Line joining S1, S1, I1 and S1, I2, S2, I2 will give another point P2. Hence, this will be my lens. This will be the plane of my lens. Now here given that 24 root 3 is equals to S1, S2. Now consider the equilateral triangle have side length A. I can say that A by root 3, sorry, it is only 24. A by root 3 is equals to 24 and A is equals to 24 root 3. Consider the image source system to be S2 I2. Okay, we know this will be A by 2, and A by 2 is 12 root 3. So S2 P2 is 12 root 3. So the perpendicular distance of S2 from the lens is 12 root 3 into root 3 by 2, which will give us 18 units. Similarly, perpendicular from I2 on the lens will be 18. Thus 1 by f is equals to 1 by 18 into 2. From here f is equals to 9 units. Hence we get our result. Well, we can prove the same for the system S1 I1. You can calculate that the distance of S1 from the lens or the line P1 P2 is 6 units, and I1 from the lens is 18 units. So 1 by 6 minus 1 by 18 is equals to 1 by 9, which is equals to 1 by f. So in either case, we'll get our answer as 9 units. You might be wondering that why I didn't consider the other case, that S1 S2 add vertices. Well, you can take it as an exercise for yourself. In this case, you will end up with a contradiction because the case is too symmetric. The case is too symmetric to be dealt, and you will eventually end up with a contradiction. I can assure you. So, thank you. Have a nice day.